You see them everywhere, right? From electric cars to the giant machines that build our world, there's an incredible invention humming away, usually hidden from view. It's the electric motor, and it has a fascinating secret. Today, we're going to pull back the curtain and look at the invisible engine that makes it all work.
I mean, if you just look at one, it's a solid, static chunk of metal. You don't see any pistons pumping or gears turning. There are no clues about what's happening. It's a total black box.
But the second you crack it open, you see this beautiful, intricate world of copper windings. So that's the big question, isn't it? How does this thing, with no obvious moving parts on the outside, use electricity to create such smooth, powerful rotation on the inside? That's the mystery we're going to solve.
To figure this out, we've got to peel back the layers, kind of like an onion, and look at the fundamental pieces that actually generate the force.
The whole secret starts right here, in what's called the stator. Inside, you'll find 3 totally independent sets of copper coils. For our purposes, we'll just call them red, yellow, and blue. And look at how they're arranged. They're spaced out with perfect geometric precision. Each one is exactly 120 degrees away from the next. And trust me, that layout isn't a random design choice. It's the key to absolutely everything.
So let's think of these 3 windings as our main characters. Each one is about to create its own invisible force field. They're setting the stage for where the real magic is about to happen.
Okay, so when we feed a 3-phase alternating current into these windings, each one generates its own magnetic field, its own flux. But these fields aren't just sitting there. They're constantly oscillating, growing stronger, then weaker, and even flipping direction. And here's the critical part. Because of that 120-degree physical spacing we talked about, their cycles are perfectly, beautifully out of sync with each other.
So we've got 3 separate magnetic fields, all pulsing away. But the rotor, the part of the motor that actually spins, doesn't feel 3 different tugs. No, it only feels one single force, the combined, or what we call the resultant, magnetic field. It's simply the sum of all 3 of those individual fields at any given instant.
Now, to really understand how this resultant field works, we're going to do something that's, physically impossible. We're going to hit pause on the universe and just freeze time to analyze exactly what these fields are doing at one specific moment.
And our first snapshot is going to be right at the very beginning of the electrical cycle. Let's call it time 0.
All right, first up is the red phase. The sign of 0 is, it's 0. So at this exact instant, the red winding is producing no magnetic field whatsoever. It's basically taking a nap. Simple enough.
Next, let's look at the yellow phase. Because it's 120 degrees out of sync, its value is already strongly negative. It's pulling with a pretty significant force, but in the negative direction.
And finally, the blue phase. At this exact same moment, its value is strongly positive. It's actually equal in strength to the yellow phase, but it's pulling in the complete opposite direction.
Okay, now for the big reveal. Let's add them all together. We have 0 from red, a strong negative pull from yellow, and a strong positive pull from blue, and when we combine all of those forces, what do we get? We get one single powerful magnetic field that's pointing straight down.
Now here's a super crucial point. The strength of this combined field is intense. It's exactly 1.5 times the maximum strength that any single winding could produce all by itself. So remember that number, 1.5. This proves the force isn't pulsing, it's steady and strong.
So that was just one moment frozen in time. But what happens if we unfreeze time and let the cycle move forward just a little bit? Well, this is where everything changes.
We're going to jump ahead just 30 degrees in the cycle and run all the numbers again.
Okay, so at 30 degrees, our red phase, the one that was at 0, is now positive. It's woken up and is now contributing to the field.
The yellow phase has continued on its journey and is now at its peak negative strength. It is pulling as hard as it possibly can in that direction.
And what about the blue phase? Well, it was strongly positive, and now it started to weaken a bit, but it's still providing a positive force.
So, let's add up our new values. What do we get? A new resultant field. And here is the absolute kicker. Its magnitude, its total strength, is still exactly 1.5 times the max. It hasn't gotten any stronger or any weaker.
Just look at this comparison. On the left is our field at time 0. On the right, our field's at 30 degrees. The strength is identical, but look at the arrow. It has physically rotated. This is it. This is the entire secret. The field itself is spinning. What we just proved with a little bit of math is the fundamental principle that makes a three-phase motor work. The math isn't just numbers on a page, it literally becomes real, physical motion.
So, to sum it all up, you take three simple, separate sine waves, three oscillating fields. You combine them at every single instant, and what do you get? You create one resultant field. And that field has a constant magnitude, but its direction continuously and smoothly rotates in a perfect circle, pulling the rotor right along with it. That is the invisible engine.
And that just leaves you with a pretty fascinating thought. We just saw three really simple waves add up to create something as real and tangible as physical rotation. It really makes you wonder, right? What other complex, incredible behaviors are hiding all around us, just born from the simple combination of a few predictable patterns?